When we are solving quadratics, we have a few options. And so today we're going to talk about when we can use the square root method. So looking at example 1, we know it's a quadratic because x is squared. And we also know when it's a quadratic, we should expect 2 solutions. So most of you could do this problem in your head when you ask yourself what number squared is 25. And most everybody usually comes up with 5. But we also have a second solution. So you have to think what else, when you square it, you'll get 25. Well, the other solution is a negative 5 because negative times a negative is a positive. Now this is how we would show our steps. I'm going to write this again. So this was our original equation. And so notice it doesn't have a linear term. That's really an important point to make sure that you recognize. The reason we can use the square root method is because there's a linear term missing. You don't see like a 5x or a 3x. So it only has the quadratic and the constant. So when that occurs, we can take the square root of both sides. And then we would say x on the left because the square root of x squared is x. And then when we take the square root of 25, yes, it's 5, but it also could be negative 5 because a negative 5 times a negative 5, that's a pair, is going to be positive 25. So that's how you get your 2 solutions. Now let's look at example 2. Once again, it's a quadratic with 2 solutions, but it has a coefficient in front of that x squared. Really, you want to always isolate the squared quantity. So how would we do that? Well, it's 3 times the squared quantity. So I want to do the opposite of multiply. I'm going to divide both sides by 3. Much like you would do if it was 3x equals 108. And so that gives you x squared equals 36. Then it's a much simpler equation when you take the square root of both sides. Keep in mind you're going to get 2 solutions, so you should have x equals plus or minus 6. Okay, now let's look at a problem that's a little bit more complicated. We have the quantity x plus 3, that quantity is squared, equal to 100. Now, I always talk about make sure your answer is reasonable. So many of you could probably do this problem in your head, at least for one of the solutions, because we know what squared is 100. Most of us know that 10 squared is 100. So what would have to go in that parentheses? Well, 7, right? If I had 7 plus 3 squared, that would be 10 squared. So you may be able to come up with some solutions just by looking at the problem, but I want to show you how we would solve it mathematically. So is the squared quantity by itself? It is. It's a binomial, but it's still that squared quantity by itself. So we can go ahead and take the square root of both sides. Now, before we go any further, I do just want to remind you of this simpler problem. If you ever have trouble, go back to what did I do with a simpler problem. So with our x squared equals 25, we took the square root of both sides. And so on the left we had x, and then on the right, remember, we had plus or minus 5. So the same thing's going to happen with example 3. When I take the square root of the left, I have just x plus 3. But when I take the square root of 100, I have to remember that I'm getting 2 solutions, plus or minus 10. So it's really the same process. Now I need to get my x by itself, and so I would subtract 3 from both sides. And what does that look like? Well, I'm going to write it as x equals negative 3 plus or minus 10. So where do my two solutions come from? One of the solutions comes from negative 3 plus 10, and one of the solutions comes from negative 3 minus 10. Well, what is negative 3 plus 10? 7, which is actually what we were able to do in our head before we started. And then negative 13 is my second solution. Sometimes you'll see that in set notation, you know, negative 13 comma 7. And that is an intro to square roots, solving quadratics with square roots.